Hi everyone, welcome back to our channel. Today we are going to find the derivation of the average power consumed by an pure capacitor. Okay, so here we have the formula for power is equal to small v into small I. So we can write down it as a v m sine omega t, where I can write down it as a I m sine omega t plus pi by 2. Okay, and already we know that, so sine pi by 2 plus omega t. Okay, so here you can write down it as sine 90 is how much, cos omega t. Okay, so from here I can write down Vm and Im is the common term, and here you are going to have sine omega t and 90 plus theta all silver teacups. This is all silver. So we are starting with sine, therefore you are going to have plus, which is nothing but here you are going to have cos omega t. So we have the formula as 2 sine theta cos theta is equal to sine 2 theta. Okay, but I require sine theta plus cos theta is equal to sine 2 theta by 2 from the basics of trigonometry. So from here I can write down Vm into Im into sine theta plus cos theta. I can write down it as a sine 2 omega t divided by 2, that is equal to Vm Im by 2 into sine of 2 omega t. So whenever the frequency is doubled, so 2 into this is the fundamental frequency, the frequency is doubled 2 times, automatically this magnitude is 0 over an cycle. Now let us try to prove it. Okay, so I'm going to integrate over an complete cycle 0 to 2 pi. We have Vm into Im by 2 into sine of 2 omega t. Okay, so when you perform the integration of this term, you're going to get it as a 0, is what we need to prove. Okay, so when you perform this, we are going to have Vm Im by 2 integral of sine theta is how much, minus cos theta. The same we are going to have here. So integral of sine theta is nothing but minus cos omega cos theta divided by 2 into omega t is 1 by 2. So it's nothing but integral of sine theta is how much, cos theta, and here you have 2 theta, that's why you'll get in denominator. Therefore this is minus Vm Im, 2 into 2 is how much, 4, which is cos 2 omega t, and integrals are varying from 0 to 2 pi. Okay, integrals varying from 0 to 2 pi, so which is minus Vm Im by 4 into cos of 2 into 2 pi minus cos 2 into 0. So when you draw the sinusoidal waveform, this is a sinusoidal waveform, and this is cos waveform. It starts with 0 and it comes here and it goes here and it is 0. Okay, so now what is cos 2 pi value? Cos 2 pi value is how much, 1. Okay, 2 pi value is 1, and cos 0 is also how much, 1. So 1 minus 1 both will get cancelled out. 0 into anything, here you are going to have the formula for power. Okay, so the formula for power, we are going to have the average power consumed by our capacitor is equal to 0. Okay, so the meaning here is this capacitor is a pure capacitor, it will not consume any power, therefore the average power is 0, and the energy consumed by the capacitor is given by the formula of cv square. Okay, now let's try to verify these two statements. Okay, so now let's try to draw the two equations of voltage and current. V equal to Vm sine omega t, and I is equal to Im sine omega t plus pi by 2. Now let's try to draw the waveforms. Okay, so in the x-axis we are going to draw the voltage waveform very clearly. Okay, so this is the voltage V of t, and when you mark it, you are going to have V m, and here you are going to have minus Vm. Okay, and this is plus 90. Plus 90 means it is starting with positive magnitude. Let's try to draw with an black colored one. Okay, so this is 90, 180, 270, 360. Okay, so the waveform will start like this, and it comes to 0, and once again it flows like this. Okay, so at t equal to 0 or theta equal to, so this is and the x-axis you are having the angular theta or omega t. At t equal to 0, the magnitude of I is positive, therefore here you are getting the phase angle of plus 90. Okay, so when you draw it back, you are going to have a phase angle of 90. So now let's try to draw the power graphs. Okay, so voltage is positive and current is also positive. So in the first 90 degrees, what happens? First, up to 180 degrees, what happened? Up to 270 degrees, what happened? Up to 360 degrees, what happened? So here voltage is positive as well as current is positive. Both plus into plus is how much? Plus. Therefore this is the magnitude of power. So here voltage is positive, current is negative. Plus into minus, once again we are going to have the negative. Okay, and here voltage is negative and current is also negative. Negative into negative is how much? Positive. Okay, so here voltage is negative, current is positive. Positive into negative is once again negative. Okay, so I'm drawing the overall view of the diagram. The power has highest magnitude, and here also the power is of highest magnitude, and it flows like this. So the area of a positive half cycle and negative half cycle both are same. So whenever in a positive half cycle you have positive area and the negative you have a negative half area. Therefore, the average power consumed by an pure in the capacitor is 0. And similarly, uh, here also in the half cycle you have equal area in positive and equal area in negative. Therefore, the energy consumed by a capacitor is given by the formula half CV square. This is all about how a capacitor stores the energy in electrostatic form. So here it stores the energy by a technique of electrostatic form. Okay, and how it discharge the energy in the form of electrostatic form. Okay, so this is all about the behavior of a capacitor and the power. So the overall conclusion is capacitor will not consume power, it can just stores the energy, and after storing energy, whenever the source is not available, it will send back. So this is all about the capacitor under steady state behavior. Okay, so thank you for watching. If you feel my explanation is good, please like the video and share with your friends. And if you have any doubts, let me know in the comment section. And if you're watching my channel for the first time, subscribe to my channel with the name kvthulasi. So kindly support this sort of a free channel for the development of students and faculty. Yours obediently wrong.